Hey everybody, welcome to my talk about our journey with design systems and web components at Chatham Financial. I have a lot to cover, so let's jump right into it. Today we're going to discuss why design systems and centralized component libraries can have a major positive impact on your organization. Then, once you're all convinced, talk about the architecture and deployment models that will make your design system succeed in the long term. So first, I want to take a little bit of time to convince you guys that this is the right thing to do. I'm going to give you a peek at our design system and then a few applications from before we adopted one. They all work well, of course, but you'll start to notice some of the issues that arise from not having a centralized design system. Firstly, let's define a design system. A design system is a standard of how components on your web page should behave. These components are usually the basic ones like selects, tabs, buttons, and inputs. Our design system has about 30 of these components. You can see some examples here. The components of a design system are intended to be used at scale and can be implemented in code rather than just in English guidelines. Now, let's take a look at what often happens without one. Here's a shot of one app. It's a little bit gray, it might not win any design awards, but it's functional. The first page you see isn't necessarily the problem with not having a design system. It's the second page, and the third. This page is a bit older, but notice how different it all looks. The headers, the collapsibles on the right, and the different background all stand out. Now let's take a look at a page of a similar vintage. Notice the different headers and collapsibles on this page. It's all bespoke. Think of how many wheels have been reinvented here, how much work has gone into each collapsible, select, tooltip, button, etc. And also think of how hard we had to work to avoid accessibility, internationalization, and performance mistakes. If you keep redoing the same components, you're also rediscovering and refixing mistakes. Of course, a consistent look alone isn't necessarily going to make your accessibility better, but this leads us into why you should centralize your components' code and behavior as well, because there's a lot of benefits to doing it once and doing it right. All these aspects of your app can be shared, because most of them need to be done in the same way across apps. For example, consider the humble select box, where you can pick an option from a drop-down list. Regardless of where that select is, we expect it to work with assistive technologies and non-Latin values. We also expect it to be searchable and navigable with the keyboard in the exact same way every time. If you press the End key while it's open, it should take you to the last value, and a developer shouldn't have to remember to add that themselves. This allows for a major efficiency improvement, and in addition to the required stuff like accessibility, we can implement things like debouncing and masking in one place, instead of having each app find its own solution. So hopefully I've convinced you of a design system's usefulness. But before we get into the nitty-gritty architecture, I do want to talk about some of the social barriers your organization may need to overcome when switching to a design system. Before the introduction of one, we functioned as a very prototype-driven organization. Our designers would hand us these ultra high fidelity prototypes, and we made sure they matched the prototypes to the pixel, regardless of whatever CSS trickery that took. People usually only pushed back on prototypes if they would take an inordinate amount of dev time. So, if a designer made a mistake or insisted that something look a certain way, we had to pay for it in dev time by adjusting whatever shared styles we did have to match the prototype exactly. Now, because we have a design system, that to the pixel level of control is no longer in the hands of the designer. If the design system and the designer conflict, the design system wins. You may think that designers aren't huge fans of this process, but I found that most of the friction actually comes from developers who are still in that prototype-driven mindset, trying to modify the design system because somebody accidentally used an old checkbox style or mistakenly placed an icon one pixel too low. The designers are quite happy to conform to this system, actually, because they understand the benefits of doing so. To mitigate friction, I think it's important to explicitly set expectations with developers, both at the point of adopting a design system and through your training material going forward. If a developer can't match the prototype to the pixel, they should know to ask their designer what's up. We're also going to start reviewing prototypes for design system compatibility before they reach the hands of our developers, which should allow us to know ahead of time whether additions or changes to the design system need to be made. Of course, styling and look aren't the only points of friction between developers and design systems, so I'm going to spend most of my remaining time talking about how to ensure your developers are happy with the components from a behavioral point of view. Now, I'm sure many of you have your own internal component libraries, and what I've said so far isn't too surprising. There are, however, a few semi-recent technologies that I'd like to highlight which may be of help to you. Firstly, custom elements are a somewhat new web standard which allow you to define your own components without the use of a JavaScript framework. Shadow DOMs serve to encapsulate these components and are also fully supported by all the major browsers. We use Stencil for this, but each framework has its pros and cons, so you'll have to select the right one for your organization. Using these standards allows you to interoperate with the major JavaScript frameworks like Angular, React, and Vue, as well as vanilla JavaScript and jQuery, and, because it's a web standard, whatever framework will come next, unlike something written in purely Angular or React. Below is an example of one of our web components. You may notice that we have some version data in the tag itself there, and I'll get into why later in this talk. One thing I really want to emphasize is the point of a design system. It's to be used as widely as possible across the company. That means even for smaller companies, you're going to have upwards of 100 developers banging on it every single day, finding every single corner case and wanting to use it for things that you wouldn't have even imagined. This means that it has to be flexible in the extreme. In that vein, let's talk about state reducers for a moment. A state reducer is just a function that takes the current state of your app and some new information, usually an event, and then returns what the new state of your app should be. If you're familiar with Redux or NGRX, they're used really heavily in those frameworks. As an example, PowerPoint will advance the slide if you scroll down and go back if you scroll back up. So, if we were to describe that behavior as a state reducer, we'd say it takes your current state, the slide number, and the new information, which is the mouse event. If the mouse event is scrolling down, you add one to the current slide number. If it's scrolling up, you subtract one. These aren't always explicitly single functions, especially in legacy code, but the concept still applies. So if you want to change how the mouse wheel behaves in PowerPoint, you'd have to modify that state reducer. That's true for most applications. Controlling the state reducer controls most of the application's behavior. So, getting back to writing a flexible design system, if we give our users control of the state, and therefore its reducers, they control most of the behavior. Hopefully that's convincing, but I prepared a quick example to illustrate. In this design system, we've not heeded my advice, and we've added some state internally in the design system. Let's pretend it's the modeled value of a select or something. The variable itself is represented as a gray box, and the arrow looping to and from it is the state reducer. With this, the select works. However, somebody is eventually going to want to be able to set the value from the application. That's not a big deal, since we can just add a setter. While some applications can certainly get away with just setting it to a constant value when something happens, many applications are going to be more complex. Some applications will also need to take the current state of the select into account when setting it. So you'll need to send up an event with that state whenever it's updated. And the consuming application will need to keep track of it themselves. This is effectively two-way data binding, which can be difficult to keep in sync. Of course, we also haven't considered events within the design system which update the state, such as clicking a new value, and events from within the app which also may necessitate setting that state. You need to remember to synchronize both pieces of state whenever that happens. Of course, this might not be a problem for your conference goer, but remember that there are hundreds of people working on hundreds of components every single day. This places a lot of mental load on the consumers of these components, and we want to make sure that even the most sleep-deprived or distracted person is not going to cause the states to get desynchronized, write an infinite loop, or cause some other kind of nasty bug. So as I advise, we can just take the design system's state out. Instead of a setter, we have a read-only prop, and the design system sends up events and maybe suggestions as to what the new state should be, but it's solely bound by whatever properties the application sets. So that way, whenever you get one of these questions, you can just tell them this. No need to synchronize anything, and you wind up being able to support a lot of these features by default. Of course, this also works really nicely with state management patterns. With this, you can effectively guarantee that there's a single auditable source of truth in your application, which is incredibly useful for reliability, ease of debugging, and making your apps simpler to reason about. Now, you may be thinking that this is a bit optimistic and you can't possibly make a stateless design system, and you would be right. There are times when the benefits of adding state outweigh the drawbacks. Let's consider what types of state might be worth adding then. Firstly, a completely stateless design system would have to do a ton of pointless recomputing of derived values. For example, we wouldn't want to recompute the element offsets of a virtually scrolled viewport, for example, on every single frame of the scrolling animation. That would be a little silly. The good news is that if your design system is nearly stateless, it's likely that most of your functions are pure, so you can memoize a lot of those more time-consuming computations, and the state penalty of doing so is completely hidden from even you, the developer. We actually do this with size 1 caches a lot, so you're not doing the same computation on every single frame, but you're only using O1 memory with your memoization cache. Debouncing and throttling are also incredibly important tools to improve UX, and their timers, while technically stateful, are again hidden from you, the developer. This is another instance where I wouldn't think twice about adding some state to the application. In addition to the state that is fully encapsulated from you, the developer of the design system, you're also usually safe in adding a state that you know will be fully encapsulated from the consuming application. For example, the consuming app shouldn't care about the x coordinate of your mouse when you're dragging and dropping some table column, or the element in a select which is highlighted when you're navigating it with the keyboard. It would be really annoying for the consuming app to keep track of that, and there wouldn't be much benefit to it. The one borderline thing here is staged values in form-like components, like multi-selects or date range pickers with apply buttons. Usually consuming apps don't care about this, but you need to make a judgment call on whether encapsulating the state from the consuming apps is a good idea for your organization, and you may need to tell some people no in the future because of your decision. However, we chose to encapsulate most of these. Finally, stuff that your app might rarely care about but isn't likely to need extensive synchronization and would be really annoying to keep track of in your state management is also a reasonable thing to add to your design system. For example, whether a tooltip is currently displaying, a dropdown is currently open, or whether an input is focused. Those are all relatively minor states. So taking that into account, our design system has 50 to 60 pieces of state that aren't element refs or debounce timers or memoization caches, and those are spread across 30 components. We don't have any modeled values stored as state, so we've achieved a really high degree of flexibility with this architecture, which means when somebody asks to do something a little bit out of the ordinary, we're usually able to accommodate them while putting in either no or minimal work. Ever since we nailed down this architecture, I've had a lot of Slack conversations like this, where somebody asks for a new feature, and I tell them that the design system is already capable of what they want to do, plus or minus a small change or two. You may think that some of these out of the ordinary behaviors may amount to hacks, but at the very worst, they're well-tested, accessible, performant, and brand compliant hacks, which will continue to work over time due to our commitment to this functional and stateless architecture. So I would take that over writing something new any day. Now, notice that I said over time there. Another tenet of our design system is our updating model. We actually immediately hot push new minor versions of our design system to all apps which use it. This might sound a little bit shocking to some of you, but I'm going to explain the benefits of doing so. So firstly, the point of a design system is to make every app look the same and have the highest quality of orthogonal features, like accessibility and performance. However, by making your design system a manually updated dependency, you're limiting that benefit only to apps which are under active, high-throughput development, because those are the only apps that are going to manually update your system. This is another frame of mind change that your developers may need to understand. By pulling in our design system, they're subscribing to the latest updates, so the app may change a little bit from under them. Of course, this is going to cause some friction. Even the best developers add in bugs from time to time, and it can be very frustrating to discover a new bug that seemingly was added under your nose, and possibly at an inopportune time. Because of this, it's important to fix bugs as quickly as possible, especially high priority ones, and make sure your developers feel like they're being taken care of. They're going to have an inherently biased viewpoint because they're much less likely to notice a bug fix that was hot pushed to them if they haven't yet encountered the bug which the bug fix fixes. It's important to assure them that the library's stability and quality are your top concerns and walk that walk. If your developers feel assured that the total number of bugs in your library is steadily going down, they're much less likely to complain. Thankfully, hot pushing actually does a lot to quicken up your cycle times and make it less likely that bugs pop up at inopportune times. Let's look at another egregious use of PowerPoint to see why. All right, I apologize for the Gantt chart here, but let's break this down. So here we have two streams of development, the design system and one app that consumes it. The app didn't heed my advice and decided to manually update the design system themselves. The consuming app needs a new design system feature, so after adding some fresh and fun bugs to the system, I get around to implementing it. On Wednesday afternoon, I tell them that the feature is done and they can update their system to start using it. After updating, they go about using it. All good. However, one of the team's testers finds those bugs I added late on Friday, and after a bit of root causing, I get word of it on Monday afternoon. I also hear that they have a demo on Wednesday, so I need to scramble to get the fix out the door and make sure their app works well enough for the demo. In addition, although they can spend Monday and Tuesday verifying other parts of the app, they can't verify that the bug is fixed until I finish fixing it and they update their design system to the fixed version. We both spend Tuesday afternoon in a panic, and everybody is unhappy about the situation. Now let's compare this scenario to an automated version of the app. Same thing, but because the bug was present in their application as early as Tuesday morning, right after I added the bugs, their tester now finds the bug on Wednesday afternoon and gets it to my desk on Thursday. Because they got it to me so much earlier, I didn't have to drop everything to fix it, and because I got the fix out before they started testing the app for their demo, the development cycle is totally unimpacted. Now, this may sound like I'm being very generous towards the application with automatic updates, but this situation occurs all the time. So let's bring in that other scenario to compare. So the first thing that's different for the automatic app is that the bug is discoverable much earlier because it was hot pushed to the automatic app on Tuesday morning rather than being pulled in by the dev team on Wednesday afternoon. You'll notice that there's roughly the same amount of time between the bug being present in the app and the bug being discovered for both projects. This isn't unrealistic because there's a large amount of passive manual testing that your developers and testers do each day just through the normal course of developing the app. They're going to inevitably press some buttons, use some selects, and row through those tabs in just the natural order of checking the code that they wrote or trying to figure out why an integration test might have failed last night. These are all great opportunities to discover these bugs. And in addition, it's not just a one-to-one relationship. If those bugs are hot pushed to every single app, your team is extremely unlikely to be the one that notices the bug in the first place, because some other team will have found it first. There are situations where I've added a bug in the morning and I got word of it before day's end because there were 10 or 20 people who used that component during the day. One of them was bound to notice it. In addition, not having to spend developer time updating the design system does yield a small efficiency improvement, which let the automatic team claw back a little bit of additional time for verification. In addition, when the bug was fixed, they didn't have to update it again, so it didn't disrupt their development or testing process. This is a very small amount of time saved, but when you consider that one developer probably takes 15 minutes to update it, push the change, get it approved, and then every single other developer has to restart their development server and resync their dependencies, then you multiply that by 10 projects in flight, then you multiply that by a few times a year, and then you multiply it by the fully loaded cost of your developers, and you do start to save non-trivial amounts of money doing this. Of course, if you're going to do it this way, you need to be very cognizant of stability and very conservative about breaking changes. You're probably going to have a lot of breaking changes to fix mistakes in the beginning, but as your system matures, you should aim to have as few breaking changes as possible. I'm going to punt this discussion of what should be a breaking change to another excellent talk by Rich Hickey. Most of the advice he gives there is exactly the advice that I would give. One thing I will encourage, though, is that as you make breaking changes, make it as easy as possible to upgrade. Developers generally don't have the time to spend an entire sprint upgrading every single component and verifying the results, but allowing them to use multiple major versions at once will allow them to gradually upgrade. In addition, make sure to continue hosting old documentation and backport small things upon request. In the same way a huge Disney fan is likely to go out and try some new ride at their parks on opening day, a developer who is happy with the level of support they receive from their design system team is more likely to upgrade on day one and to help you suss out those bugs before other teams would find them. Finally, I'd like to acknowledge that if you're writing apps with a very picky and very conservative clientele, this may not be the route to go for you. But hopefully I've convinced those of you with large numbers of internal apps, or maybe clientele more convinced with the appearance of continuing support and improvement, of the merits of this system. Everything is a trade-off after all. Now, before I turn it over to questions, I just want to go through a few more things which should hopefully inspire you to centralize your front-end components and reap the benefits of doing so, because you really do stand to gain a lot through this degree of standardization. For example, here's a dashboard that we developed for one of our corporate clients. You'll notice that in my browser's add-on area, there's a photoshopped version of our logo in the shape of a smiley face. This is actually an accessibility linter, which is able to provide significantly more and more useful tips than your browser's built-in accessibility tooling. This is because using our design system gives the linter much more semantic information about what you're trying to do with every component. For example, if you forget to label a select, we know it's a select, and we know that it should have a label, whereas tooling naive to the design system might only see a bunch of divs and not know what to do about it. Here's an example of a much older web app that was written during the transition to using our design system. You can see that the accessibility linter is now showing a frowny face and is able to identify elements of the design system which are missing labels or could otherwise be made more helpful to assistive technologies. It's also able to highlight where they are on the page and even show them in your dev tools if they're currently hidden, for example. We're also able to tell developers exactly how to improve the situation and link to additional documentation. However, this page only partially uses the design system. Those buttons on the left of the input are bespoke, so both we and the browser's accessibility tooling can't automatically check them because they're just a bunch of divs. A clean bill of health from this tool doesn't necessarily guarantee that your app is fully accessible or passes any standards, but it does a lot ensuring that we're not making the simple mistakes. And it reminds developers that accessibility can't be an afterthought. It's in their add-on bar after all. As for whether anthropomorphizing your linter with smiley and frowny faces improves compliance, that's still a field of active investigation. Finally, I want to talk about where we can take these technologies that we're using for our design system. Because web components are so flexible, you can add them to anything from an ancient ASP.NET app written in Razor to brand new apps using the latest versions of Angular and React. We've taken advantage of this to make micro frontends for universal portions of our website, like the navigation bar. And because we're using the same hot push updating philosophy, we're able to update those hundreds of ancient and modern apps alike with a single deployment, rather than having to go through each one or deal with iframing. For example, we're adding a global notification tray to each app, even the ancient ones, and we've only needed to allocate one developer part-time to this feature because our updating policy will ensure that they all get it. We're also able to justify putting true effort into writing documentation. Most of our components, and especially the complex ones, come with tutorials, troubleshooting steps, FAQs, and full documentation of each property, event, and slot content. And we're also able to provide a place for developers to play around with it in a controlled environment, which we found significantly increases developer comfort with the system. It also makes reproducing bugs a lot easier. Remember, it's all about taking care of your developers and making them feel supported. There are tons of other things you can do to improve efficiency at the scale, like writing lint rules, which can automatically upgrade you to new major versions of the system, or libraries, which can standardize a lot of the boilerplate you'd find in tests. But hopefully this was a sufficiently inspiring taste for the 30 minutes that we've had together. And with that, I'd like to thank everybody for watching and the organizers for making this talk possible. And if time permits, I can field any questions that you guys may have. Thank you.